here's what we have today. This is kind of a little, it's a little nicely cooled laser source. It's, I picked this up. One of the ongoing products I have an interest in is a selective laser sintering of like a plastic powder for rapid prototyping. And this was one of the things I picked up in kind of looking into that. Didn't wind up working out, but this is a max 500 milliwatts class 2 laser product. So this is, it's actually quite a neat little device. It's actually cooled internally. There's actually a fan in here, oops, if you can believe that. So anyways, it's just been sitting around for the last year, and I think I've misplaced all the documentation on it. So I figure we'll just take a look inside of it. So you can see it's just got a little fiber coupler. So what I will just do, I believe I've been in here to some extent. You can see it's just got a bunch of 0.1 inch pin headers. So we will just, if I remember correctly, it should just make some horrible squeaking noises. So here we are. So you can actually see this is quite neatly designed. A little loud. So the way this works is you can see the only venting here is this venting around here, and the back is completely covered. So if you look at the little fan here, what actually happens is it pulls air in on this side, flows like that through the circuit board. You can see there's holes in the circuit board, back along this heatsink here, and then out this side. And we can look down here and you can see that there's a couple power devices down here. This is a let's see, that's all the way in. So we have a mic 29302 BT, an Apex PA26, and there's one more device down in there which I can't read the number on, but I think we will get in there. So what I'm going to do now is just, these are just socket cap screws. Let's see if it's metric or standard. That is not, let's see, was that, that's one, it's not 1.5 millimeters, so it's presumably standard. Well, made in the USA, so yeah, it's almost definitely US. So that's a .050 Allen wrench. So with any luck, I'll actually be able to get into the optics on this one, because Mike really wanted to see the optics on the interior of the that other device. So if I believe this is actually Peltier regulated. I'm not completely certain, but so there's just a little back plate. There's the cooling fan. You can see it actually looks like there's space for another module here, and that looks like an SMA connector. Also of interest is the fact that if you look here, there's I don't see anywhere the traces from that SMA connector could escape, so that means this is presumably a 4-layer board, and they may be doing RF stuff on the interior layers. You can also see over here, those look to be the connections into the laser head. I don't see, oh wait, there's also a few pins down in there which run into the laser. So let's see, I think I'm going to have to take the head apart first, because I need to be able to get in there to, well, let's see, let's try one size up. That works. Let's see, since this is a ball driver, I can go in there at an angle and, ha. Let's see if it'll come all the way out. Okay, so it looks like I may be able to remove the heatsink. I'd be more bothered, but this was only like 30-something bucks. And kind of, I've moved several times recently, and once I have shit lying around for more than, you know, a year, I just kind of reach the point where it's like, okay, I gotta just get rid of this. Because I just can't have that much crap. I tend to be I'm a pack rat by nature, if not by choice. So I kind of have to be very aggressive about clearing up stuff that I haven't used recently, just because then I just wind up with just giant piles of electronic garbage. Well, stuff that could potentially be useful, but you know, it's kind of like, have I used it? Have I done anything with it in the last year? If not, just move on. A lot of the stuff, it's like, is it really worth my money and time to store it? If I spend 2 hours, you know, organizing crap, that's, you know, $50. You know, so you just have to be really aggressive about cost-benefit analysis. Let's see. You know, just otherwise you just never get rid of anything. It's using slotted screws, which is kind of interesting. Let's see, is that... Okay, it appears that this... I'm actually freeing it up in the wrong direction because I'm now fairly confident that this heatsink is bolted into this assembly here. As you can see, the board kind of wiggles. Is there any easy way to desolder that? Alright, so... Where is my spinner? There we are. So there are 4 fairly prominent hex cap screws set down in here, which look to be one size up even more. Yep. Another thing you might notice is that there's a bunch of what looks like epoxy kind of glooped around this surface there. So I'm hoping I can get this apart without having to, you know, physically tear it apart. One thing I've noticed, these are pretty damn long screws, so that, you know, is making it all the way in there. Ugh. Fortunately, these don't seem to be that tight, which is kind of nice. Okay, so that's interesting. So it appears that if you look down in there, it looks like this is using a TO2 or TO52 laser diode package, because you can see the edges of the diode can in there. So I'm interested in how they fiber couple this, because I mean you can see straight through there. So I think there may be some free space optics in there. You can also see. Focus. Fortunately, the camera loves to snap to autofocusing on my bench because it's got a nice texture. You can also see there's 2 big hex wrench, 2 big socket cap screws right in there. Oy. So this may in fact not be cooled. I thought it was. But you can see that there's 6 connections here. So it looks like these connections, which are kind of lapsed onto the board, you know, some on this side, some on that side, presumably those all run into the diode. There may be a feedback like phototransistor or photodiode in the package too. That's very common. There we go. So I think these screws just hold this angle bracket on. Yeah, it appears so. Oh, hey, nice, it's connectorized. So, that's quite nice. So that means that it's possible this board will just pull out. It also looks like there's a spring You see right in there, it looks like there's a spring over a screw, which makes me think that this has a three-dimensional kind of a tuning thing in there for precise placement. Let's see, can I lift this board over the fan? So I'm betting these two sheathed wires are like a RTD or a thermocouple of, no, presumably a thermistor. Yeah, so that was connectorized. That was correct. I've bent the pins a little bit now, but I don't really care that much. I am going to just snip these two leads. Well, these could actually be the leads to the diode, because if you look, there's a 1 ohm resistor right there. There's actually a wire lead jumper soldered over there too, which is kind of amazing. Fortunately, they seem to have... Wow, look how long those pins are. So those plug into that whole connector there. There's the power devices and some stuff on the back side. Let's see. I think this fan is probably just held on with some tape. So the fan was just double-sided sticky taped in place. So here we can see that presumably there are screws in here, but we don't care too much about those. Let me actually switch lenses so we can get a better view. So here's the board. So that's an LMC 6064. I'm pretty sure that's a low noise quad op amp, because I think I've used an LMC 6062 in some previous projects. Over here we have some micro 2920 and another 2920. I'm pretty sure those are voltage regulators just from the package. Here are these big devices here. We have an Ampex PA26. I bet that's a power op amp. C3748. That's maybe just be a BJT. And there's another micro 2930. So these are 2920s and 2930s. So I bet those are all voltage regulation of some sort. So there's two LMC 6064s. Better op amps. It's interesting, there's a fair number of unstuffed components down here. You can see there's a pad for like an S for one of these package devices over here. It's an interesting footprint. It doesn't have like a solder mask definition for the tab. There is a 0.1 ohm resistor, so that's going to be current sensing of some sort. And then you can actually see, that's interesting, there was a wide SOIC device that goes here, and a bunch of the pads are strapped together with some neat little traces there to try and make space around that via. I'm actually not entirely certain why that's like that, because it doesn't look like this section. So obviously there's a section of plane here, but it appears to not be connected to anything, so I don't know why there's a via in there stitching it, because it doesn't appear to be connected to this pad. It looks like it's just part of the ground plane. That's kind of bizarre. I wonder why they didn't just say, okay, we're not going to have plane here like they did here, or they have plane here and it's floating. If I was doing this board, I would have probably put a polygon cutout there to just get that, to clear out that plane like they did here. So here's the other side of the board. You can see you've got we have a lot of trimmer pots. There's actually 4 cute little surface mount multi-turn pots, and then we also have 4 single turn pots. There's also some 1R0, and these are all 1 ohm resistors. 20K, 20K, 10. That's a 100K actually. That's interesting. High precision, less precision. Some flux scoop. It's a footprint for a SAW 23. Some more SAW 23 devices. There's just a few parts over here. 2426C. That's interesting. An AD780. Analog devices part. That's TI branded. Over here we have an AD623. That's the instrumentation and amplifier. T45B. Here's a big 1 ohm resistor with a slightly misaligned, presumably tantalum next to it. And then the other thing you can see is there's some interesting resistor jumpers here. I think this board may have several stuff configurations, because I bet there's a connector that goes here. There's another footprint for a little connector there, I would imagine. Or it could just be via stitching. I mean, Well, no, that's going to be under a component. Footprint for another SOC 8. It's an interesting board. You can see here's this big high density connector that goes to something. And then we actually have a fly wire here. It's nicely done. It's been epoxied down. And then it's just soldered onto the one end of that capacitor. You can see here's that SMA connector, which makes me think there's an interior layer on the board because there's no connection from the center pin. That may be just a termination network. You can see bot and top 0334-0200-0A. There's another shunt, slightly misaligned capacitors. I wonder if this was partially reflowed by hand. Little MILF diodes. It's interesting, definitely a lot of these stuff, it's like you'd expect if this was properly fluxed, these components to have popped into perfect alignment, whereas a lot of them are slightly cocked. Those are really close together. Anyways, moving on. So here's the optical assembly. Okay, yeah, it's definitely got a Peltier in it, I was right, because that's the edge of a Peltier device right there. So if we look over here, you can see something that looks a lot like a spring with a screw running through it. So this may be to allow them to adjust that. And you can also see there is some little tiny hex cap screws down in those holes. Let me see if this fits this. Blarg. Alright, so let's just take this case off. Oops. Those are more remarkably long little screws. It's like 256, but it's 3/4 of an inch long. So I bet these two screws are all that hold the kind of this SMA outlet on. Oops. Let's see, am I correct? Sure seems kind of like it. It's also got some alignment pins. So yeah, it looks like there are some free space optics because as you can see there's something that looks a hell of a lot. That's a lens there. And then here we can see the so there's the actual diode package. So it actually appears my earlier assumption was wrong. These I'm pretty sure these two leads are the Peltier control leads. Because the entire diode assembly is seems to be connected through those 6 pins there. Here you can see the alignment pins for the oops. So those are kind of the alignment pins that hold this in exact alignment. And then it looks like okay, this isn't adjustment. What this appears to be is clamping springs to maintain force on the this whole assembly. So if we look down into the diode, so there you can actually see the actual diode. Let me try bringing it. Fortunately, this should do 1-to-1. Let's see, I need a flashlight. 1 second. Alright, so let's see. So there's the actual diode right there. So you can see just how it's very small. I mean, that's 500 milliwatts of laser diode. You can see there's a little wire bond running onto it. That's interesting. They're actually using 2 separate bond leads. So you can definitely tell this is the high power stuff. So one of the terminals for the diode will be basically the little gold podium it sits on. And then it looks like so actually the way this works is the diode is actually that very thin black flat section. Let me get something to hold this. My hands are wobbling everywhere. So I can't kind of stuff it into one of my helping hands. A little further out. Focus. So you can see in here, oops. So that little thin black section there, oops, I'm bumping it with everything, it can't take me anywhere. So that black, see, try and get the light on it properly. It went out of focus. Sorry, the depth of field with this lens is very narrow because you're getting such high magnification. So that black slab that you see right there is the actual diode. And then the wire bonds, there are two bonds that looks like they're distributed, kind of 33% and 66% across the length. So that's the actual diode itself. There you can see the 2 points where the wire bonds are kind of, those two little shiny points are where the wire bonds are onto the top surface. So one of the terminals is this pedestal and the other terminal is the other one. In fact, I bet if we look down in there, so the other pin, okay, it actually looks like it's not being used. Sometimes that pin will be wire bound just to the can. But in this situation, it looks like the other pin is just floating because they're not using it. This is a standard casing. So in this situation, they didn't feel the need to use both of the pins. They're just using the standard casing because they're trivially available. Let's, where's my really small hex wrench? Let me come in here. Those are springy springs. So now here's an impressively long, this is, it's either 256 or 080. I should probably actually remove these in kind of an X pattern so that the system doesn't warp. Sorry, I'm kind of obscuring everything with my fingers. Get off my little keychain line. So I'm actually not entirely certain if this has any optical feedback. I don't see any provision for it. This isn't quite as interesting as the one of those diode modules with the built-in fiber would be, but unfortunately I kind of didn't put too much effort into it, and if I still had it I'd take it apart further, but well, sorry. So here we can see that this is definitely the leads for the Peltier device, which are that little white silicon, are definitely these two flying leads. I might try powering that up, without the laser a little later. You can also see there's a little bit of a dab of silicone grease on the back, despite the fact that there's actually a hole right underneath it. So the silicone grease didn't spread very well. Oops, there we go. So just pop the Peltier off and you can see the back of the diode is very greasy. Let me just clean it off with a Q-tip so I don't get it all over my fingers, because nobody likes heatsink grease all over their fingers. Okay, that's interesting. Oops, I just kind of smooshed it down in there. So down in that hole, the little bulb in there is I'm pretty confident the thermistor. I kind of pushed, when I was trying to clean the heatsink grease off it, I kind of pushed it down in there. But that's going to be the temperature sensing for the back of this die, which is relevant because that's basically the temperature of the diode. So let me see if my hex wrench fits these little screws. Wow, that was loose. So this is interesting. What we can see here is we have a little, I don't know why this plastic shim was in there because it wasn't really crimped very tightly. But there's a little plastic shim, and then now I think, is the diode free or is it held down with some sort of epoxy? Alright, let me... Oh, look at that. It's held in with set screws. Excuse me, I'm being stupid. So it looks like we have... oh, that's interesting. So that you can see that there's... It looks like a set screw in each corner. And that way they can adjust the position of the diode within the housing very precisely. Because presumably when they bond these down, they'd have some, you know, kind of variance. I don't think even my smallest wrench is going to be able to loosen those. These are tiny. Yeah, so there's socket cap screws in there, but that's even the smallest, my .050 hex wrenches doesn't even fit in that hole. Actually, let me see. I may have some really, really fine torques that'll kind of fake it. No, even that's way too large. I think I might just pry. I don't mind about scuffing the diode housing. So let me... okay, let's go into focus again. Oh, there we go, yeah. So that wasn't anchored down that hard. So there you can see there's kind of the back side of this housing. So you see it's just got, let me wipe up that little bit of heatsink grease too so I don't get it on the diode face. Oops, that's actually a straight through hole. So now I can kind of rest this like this. So there's the back of the housing. And we can see that it appears they may be using both of those. I may have been wrong about that terminal not being wire bonded. I may try to decan this. But you can see that there's only two components here. There's the two leads running to the diode and the two leads running to the thermistor. Oh wait, my bad. So it looks like this is a generic board because you can see that there's a big trace on the top, which presumably runs to the case ground. You can also see it appears that two of the traces on there are jumpered together. It's kind of interesting. But yeah, so you can see they have those two traces, and then this thermistor is presumably used to measure the temperature of the far side of the Peltier, you know, so they can servo it. Let me get the heatsink grease off my tweezers. So over here we can see into the diode packaging a little better. Yeah, so that pedestal down there is definitely not wire bounded to anything. Whereas you can see, let's see. So there's the top surface of the diode, and you can see that it's actually, it looks to be pretty deep. I wonder if I can get this head housing off. Making it kind of, so it appears it's just bonded down in just this corner. But how was it done? It looks almost like it's been soldered. Let me see if that was it. Let me turn on my iron. Turn up to high temperature. So whatever else I may say, this was very much not hermetically sealed, which is rather intriguing. Open my beverage. Much better. So hopefully this has been just lead soldered rather than hard soldered. Okay, we're up to temperature. The chip's not as clean as I'd like it. Cool, the gold is taking the tin nicely just because it's gold. Let me try and grab it with tweezers. It appears I just desoldered the diode from the board. It appears it isn't a solder joint. It may be a like an ultrasonic, a little spot weld. That's obnoxious. Now I made it all hot and got solder all over it. Great. So appears I've soldered the portions of the joint that I had already opened. Okay, I am just going to apply force at this point. Yes, wire bond undamaged. So fortunately it appears I managed to get it open without totally tearing the hell out of the wire bonds, which is always challenging because they're frickin' delicate. So here's the laser module. Just kind of looks all nasty on the outside because I managed to gloop solder all over it. Oops, let me try and pick it up from the side. So there you can see, let's get that into, well, that's got a lot of bonds. Oops, bonding. So there is the, oops, the top side of the laser diode element, and it's actually, it looks like it has 6 discrete wire bonds. So the laser is emitted from that surface there. So it comes out this way. But you can see that the way these work is that may actually be, I wonder what kind of solder that is. It might be indium solder. A lot of the stuff is soldered with some unusual elements because you have such low melting temperature. But they solder it down to that the post, and then they go in there with the wire bonder, and it looks like those, in this situation they used a, those looked like ball bonds on that end. No, wait, no, they're wedge bonds, sorry. Can't really get quite enough magnification to make it out that well. But you can see they go in there and then they strap the top, which is basically, presumably plated with metal of some sort. Well, maybe not, it might just be raw silicon, though it's very gold tinted, but that just could be the reflections. And then they strap that to one of the feed-throughs. So basically they kind of buy the housing. Sorry, I have to hold this right in the depth of field of the camera. So then they go in there and they strap it with the, with wire bonding to the pedestal, and that's how they assemble the, they electrically connect it. And sometimes you'll actually see in these, they'll have 2 devices. They'll have, basically the laser diode on one side, and then over to the other side they'll have another device, which is basically a photodiode for feedback. And that way they can, get very direct monitoring of the optical power, the emitted optical power. Wish I had a microscope I could get closer. Actually, I have some ideas. Let me try something. I have some macro bellows. Let me see if I can get a really close image of this. Here we go. Sorry if it's so wobbly, but I've got like 10 inches of lenses hanging off my shitty tripod. But there you go. You can start to actually see the laser diode assembly. So there's the actual diode, and there's the emitting surface. I actually wonder what determines which surface it emits out of. Oh, it's probably the back of it's silvered, so therefore it lasers across the length of the diode. But you can see there the wire bonds. And those are... Sorry, it's the depth of field is razor thin. So the terminations to the post are wedge bonded, but the terminations to the top of the die are in fact ball bonded, like I thought they were. So it's 2 different wire bonding techniques. One basically involves kind of, I think they actually arc to the tip of the lead, and it actually causes it to melt and form a little bulb, a little sphere, and then that actually fits into like this cup assembly where the lead fits up through the top of it, and then they wire bond straight down. Whereas the wedge bond just uses like a wedge-shaped tip, and that just bonds the wire into the surface. Ball bonds, I believe, are more reliable, but they're also more labor-intensive. So anyways, you can see that, so those are the wedge bonds and those are the ball bonds. You can also see that, I'm not sure how this works because you see how this pedestal has been flattened. I don't know if they do that with a, just a pair of needle nose pliers, or if it comes like that. But it's interesting because the other one isn't. So one of them is You know, that one doesn't have the same surface treatment that this one does. It doesn't have the squeezed. So I wonder if this was kind of purchased with the acknowledgement that that one's going to be unused. But in that situation, I would kind of expect it to, I would expect them to have just not placed the other. So there's the, so the depth of field on this is maybe, you know, 0.02 inches. So the focus is really fiddly. So there's the surface. You can kind of see the messy soldering, which looks... It also appears that it's possible, from looking at the solder on the base of the this pedestal, that the pedestal might be soldered down. I'm actually not too sure how they make these. I mean, because one of the things I noticed earlier is there's an inset there. So I wonder if... Of course, it's also possible this is all just solder that wicked in there when I was making a mess of it by trying to desolder earlier. So anyways, there's a microscopic look at a maximum 500 milliwatt laser diode element. It's got 6 little lead bonds. So, you know, assuming there's a voltage, 500 milliwatts, it probably takes a couple watts. So they need all those wire bonds because there's probably an amplitude going through the sucker. The one thing of interest is the leads for the wire bonding are actually almost universally gold. You can wedge bond and wire bond aluminium and gold are the two metals that support wire bonding, I believe. Well, probably some other exotics, but you can't. I don't think you can wire bond copper, though. I'm just kind of talking out my ass right now. But yeah, those are almost definitely like pure gold wires. We have a couple wire bonding machines where I work in one of the labs where I work, and they have this little tiny spool of this little tiny amount of gold wire, and it's like $50 or $100 worth of wire for this little thing the size of like a thimble. Other fun stuff to do. Kind of start seeing the surface imperfections and the printing effects on. There's a real microscopic look at some of the components. You can kind of see into the MELF diode a little bit there. National Semi LM60D64. So here's kind of, look at that interesting trace layout there. Okay, never mind, it appears I was incorrect. I couldn't tell why they had this via here, but it appears that these are in fact this is a grounded pad. It's interesting, that's kind of the opposite of the thermal grounding I'm normally used to, which has, kind of a horizontal and then a vertical trace for the thermal isolation. This one uses an X shape at 45-degree diagonals. That's interesting, I haven't seen that before. And you can kind of, here's one that was, it looks like there's actually a via in that pad. That's kind of bad layout. I guess they couldn't place the via here, though I don't see why they couldn't just have pushed this trace up a little bit and placed the via out of the pad. Well, that's interesting. Look at that. It's connected like that, it's connected like that, and then there's also a connection here. But that's only on that one. This one doesn't have that. Though I don't know why this pad they bothered to connect this pad to this plane that isn't there. You can also see there's some interesting manufacturing issues here. I mean, look at the edge of that. Kind of it pulls in, and then it looks like there's a little necking there that, it's very strange. I mean, if you look at the width of this gap and then you look at how the gap narrows down over here, I don't know what's going on. They might have had some weird design. I mean, overall it's pretty well designed, though. You can actually see, like here, it looks like there's a little bit of like acid collection in these two corners here, because you can see how the trace seems to neck down a little bit, because that's a 90-degree junction. The trace necks down when going into the pad, which is a potential manufacturing issue. Most of these don't have that issue. How messy the soldering is. And they probably, I would have, if I was doing this board, I would have capped most of these vias with solder masks so that when it looks like they flowed solder across the board, maybe with like hot air solder leveling or something, a lot of the vias suck solder into them. So if they tented these vias, they wouldn't have had that problem. Here's another one. It's got 5 grounding traces. That's another trace pad that looks like it's got a via in it. This seems like this board might have had Might have been quite challenging to manufacture. They've got a lot of via in pad, and they're not plugged via in pad 2, so I'm surprised they didn't have solder thieving issues. Maybe they're just applying a lot of solder, or that could be one of the advantages to the fact that it looks like they kind of flowed solder over the whole board, is that it would have filled up the whatever solder capacity the vias wanted. Little hairs and shit. I don't think that's one of my beard hairs. There's some of these kind of interestingly misaligned parts, and it looks like a pretty cold solder joint to me. Kind of, again, I wonder if this was reworked. If you look over here, you can see there's so here's the connector that runs to the diode, and you can see that was hand reworked by somebody. You can kind of see all the flux goo everywhere. Where was it over here? I mean, so here is a 0.1 ohm resistor, so that is almost definitely current sensing for the laser diode. More interesting vias. So it's kind of a janky board, to be honest. There's the cute little fan. Whee! Injection molding remains. Okie dokie, well anyways, that about covers it.